Objective number 2. We want to construct and interpret frequency and relative frequency histograms. So we're continuing the example from the previous objective, and we're going to consider the data given in the previous example. So here's the data. So I have the data up here, and then here is our frequency and relative frequency distribution table. So in part A, we want to construct a frequency histogram. Now, when we construct a frequency histogram, remember that the vertical axis is the frequency. So if we take a look at the frequency, the lowest is 6 and the highest is 10. So we're going to go all the way up to 10 since the highest is 10. Now, if we take a look at the horizontal axis, this is the bill in dollars, because remember it's a bill in dollars. Now, I want you to notice here is that our increments go from 20 to 30 to 40 to 50 and then 60. Those are the lower class limits. So we're going from 20 to 30, 30 to 40, 40 to 50, and 50 to 60. Now again, label the lower class limits. Okay. Now what we're going to do is we're going to now draw and then write what is our values for each particular histogram. Well, we know that between 20 and 30, this should be at a height of 9, which is 9. Okay? Next, between 30 and 39, this goes all the way up to 10. Between 40 and 49, we can see that this goes all the way up to 8. And then between 50 and 59, this goes all the way up to 6. So therefore, there is our histogram for the frequency. So we constructed a frequency histogram for part A. In part B, what we want to do is we want to be able to construct a stem plot. And remember that the number 5, or the first number here, is going to be the stem, and the second number here is going to be the leaf. So we have the stem, which is 2. So that means we have a 21, and we have another 21, so we have 2 ones. And then we have a 23, so let's go ahead and mark that off. So we have a 21, and there's a 21. And then we have a 23, so we have a 1 3 there, and then another 3. And then we have a 5 and another 5 for 2 25s. And then we have a 26 and another 6. And then we have a 9. And then starting at 3, we have a 31. So we have 3 is the stem, 1 is the leaf. And then we have 3 32s. So there's 1, there's 2, and then there's 3. Then we have a 34. And then we have 3 35s. So there's 1, there's 2, and there's 3. And then we have a 36. And then we also have a 37. Okay, then we have a 41. And we have a 45. And then we have 4 46s. So there's 1, 2, 3, and 4. And we have 2 47s. There's 1, and then there's 2. And then 5 being the stem, we have 1 51. We have 2 52s. We have 2 53s, and then a 59 to complete the stem plot. Now again, the legend, 2 represents the stem, and then 1 represents the leaf, which would be 21. Next, we want to construct a relative frequency histogram. So again, the vertical axis now is going to be the relative frequency, and the horizontal axis is going to remain the bill in dollars. So if you notice here, we're still going to use 20, 30, 40, 50, 60 represents our lower class limits. And then if you notice here, the lowest frequency is at 0.18, and the highest frequency goes to 0.30. So here we can go in increments of 0.05, 0.05, 0.10, 0.15, and so on. And now what we're going to do is then we're going to label the relative frequency histogram. So if we take a look at the class for 20 to 29, the relative frequency is 0.27. So therefore it's all the way up to 0.27. And then the class between 3 and then 39 has a relative frequency of 0.30. And then the relative frequency for 40 and 49 is 0.24. And then the last one, 50 to 59, represents 0.18. Okay, next. In this next example, it says here that the relative frequency histogram below shows the ages of people stopped by police in New York City on December 1st, 2012. Some of the ages are less than 10 years or greater than 65 years, but are not shown in the histogram. So here we can see that the horizontal axis is a relative frequency going from 0.1, 0.2 to 0.3. And then down below on the horizontal axis, this is the years. So this is 10, 15, 20, 25, 30, all the way up to 65. The first part of the question here says, estimate the proportion of people stopped by police who were under 20 years of age. So if we take a look at the age of 20 here, there's the age of 20, and everything under is to the left of that value. So if you take a look at the top of the bars, that represents the frequency. So between 10 and 15, the frequency is 0.02. And then between 15 and 20, the frequency is 0.29. So if we add them together, 0.02 plus 0.29, which gives us 0.31, that is the proportion of people stopped by police who were under 20 years of age. Next question, part B. It says, estimate the proportion of people stopped by police who were between 25 and 45 years of age. So that means they got to be in between 25 and 45. So since it's in between, then what we're going to do is now between 25 and 30, the relative frequency is 0.14. Between 30 and 35, it is 0.09. Between 35 and 40, it's 0.05. And between 40 and 45, it's 0.04. So when we add them up together, we get 0.32. So 0.32 is the proportion of people stopped by police who were between 25 and 45 years of age. Next question is part C. It says, determine the age that is at the 76th percentile. And that is percent to the left. Okay, so what is the 70th percentile? Well, here at the value of 30, that is the 70th, 77. And so how do we know? Well, we're going to add the relative frequencies. So between 10 and 15, we have 0.02. Between 15 and 20, we have 0.29. We added those, that gave us 0.31. Then we're going to add 0.27. And then if we add 0.14, that gives us 0.72, which is a percentage. So that represents everything up between 10 and 30, okay, is going to represent the value of the 72nd percentile. So the age that is at the 72nd percentile is 30. And again, you can see that it lands at 30 at 70.72%. Next question. It says, identify which class contains the 50th percentile, which is the measure of the center. So what we're going to do is, we're going to go ahead and then add these relative frequencies. So if we have 0.02, there's 0.02. If we add 0.29, and then if we add 0.27, that gives us 0.58. So that means once we get to 0.27 at 25, that means we're over the 50th percentile. But that means that 0.50 is somewhere in between 20 and 25. So therefore, the class that contains the 50th percentile would be between 20 and 25.